This is it. People are not going to buy anymore, right? Or in weather, do a lot of that. Oh my God, weather use a lot of algebra. Okay? Actually, I mean, even if you think about construction, at a certain point, okay, they built it so that there is a formula between how much weight and how heavy your materials needs to be. And then it will say, this, you know, you have seen this. This elevator will hold a maximum of 12 people. That's algebra. Because they figure out that if I have more people beyond a certain way, the elevator is not going to work. That's algebra. Okay? How many of you have not heard that in terms of what algebra is? How many of you that's new to you in terms of thinking of algebra that way? Okay. You may have heard it, but you get scared about all the formulas.
I didn't make a connection with the real life the way you did
Yeah,
it, but
good.
I only think about number side.
Yes, you only think of the numbers, you only think of the solving equations and all that, okay? Very good. With that in mind, how many of you think you need me to do anything on number 1? On the first page, I'm saying, which is called variables and simplifying open expression. Yes?
If you could do 4 or 6, just
Okay.
dealing with the exponents.
Sure. Yep.
4 fours.
Yep. Any one of them with the exponent?
Yeah.
So-
Exponent, I don't even remember.
So I've been thinking a lot about this. So if I say, let's just do 3 here. 7x, what is it? xy, and then times
Negative 3x.
negative x, y to the third. So this is a times, right? Okay. So when you think about x and y's and 3x plus b and all that, I want you to think about it as a thing, okay? So I think everybody understands this part, right? If I have 2a plus 2c and then plus 3a plus say 5b. I'm just making this up. Do you understand that you can only add the things that are the same? Right? Think of them as like apples and oranges, right? You can't add apple and oranges and say they are two things, like they are not the same thing, okay? So you can only add the A's and you can only add the, that's it. You can't add the B's, there's no B, there's only one C, okay? So you get that. When you start multiplying, I want you to think of it as kind of like, they are like dots on all of them. It's 7 dot x dot y dot, now this is where a bracket will be helpful so that I don't forget. So I'm going to put negative 3 dot x dot y3. I want to stop here to make sure you understand what I just did. When you multiply something, think about when you multiply 1 times 2 times 3 times 4. It doesn't matter whether you say 1 times 2 first and then 2 times 4 later. They are all multiplication, right? They are all multiplication in this case, right? So when you do that, could I, again in math, can I rearrange it so that I group some things together?
Yes.
Right? So I want to group the numbers together, so I'm going to rearrange it. 7 times, not subtract. This is why I want to keep it in a bracket, because if I don't put a bracket, it's going to look like 7 minus 3, which is not true. I'm talking about multiply here, right? I'm talking about multiply. I can rearrange it. I didn't change anything, right? I didn't change anything. I'm just rearranging. Then I can put the x's together. Now I'm doing it slow just so that you can see from step to step. After a while, you can see the whole thing a lot faster. And then I'm going to put the y's together. Now, is there another way to write the y to the third? What does that mean?
Y
Right.
times y times that.
Right. Okay. So now the numbers are together. So what is 7 times negative 3?
21.
I can also think of it this way. Somebody was asking what happens when you multiply. Same, almost similar rule. If you multiply a positive and a negative, you get a negative. Okay? If you multiply negative and negative, yeah. Okay. So when you say negative 2 times negative 2, that's a little bit harder to explain, and I wish I had time, because when I teach this, kids actually play with chips and stuff, and then you can actually say, oh, that's what it means to multiply, you know. So too bad I don't have time to do that. So this is negative 21, right? So how many x's do I have? So how do I express that? X squared, right? And then how many y's do I have? The 4, right? So if I want to just write it out without the dots, I could just say negative 21 x squared y 4. Yeah.
So, how is x times x 2? Oh, x.
Sometimes it's language. So we have decided in math that when you multiply two numbers that are the same, you put a square there.
Oh, so it's not 2x, it's x to the
No,
second
yes,
power.
very good. 2 times x is not the same as x squared. No, not the same. So the way you want to think about it is put a number in there. 2 times 4, that's the 2 times 3, right? It's not the same as 2 to the power of 2, right? 2 times 3 is 6. 2 to the power of 2 is 8.
Right?
4.
2 to the power of 2.
Because 2 times 2 is 4 times 2.
But why do I multiply another time?
Why do we 2 times 2?
This just means multiply twice. 2 times 2.
Oh, okay. Yeah. Sorry.
That's okay. Believe me, I've done this before. I'd be like, that was the most obvious thing, and then I did it wrong.
Right.
It's okay. That's one of the most obvious thing, right? We just talk about it. Yeah. So this is a very important point. Guess what? On the test, they will give you answers that have both. All right? And sometimes you are like careless. And you go, oh, that's the answer. Oops, that was not x squared. That's 2x. Right? You could be very careful. The test will do that because they know that it's such an easy mistake. Now, does that make sense then? Instead of doing this over and over, imagine every time I have to do this, I have to like do it all over and over. What can I say? What can I say if this is a 1, right? And this is a 3, I could actually say 1 plus 3 give me 4, right? So math is really about patterns. That after a while you realize that I can use the same rule over and over, right? I can do the long way. That's okay too. If you are not sure, do the long way. Write it all out. I'm going to do, like for example, if you have something that says y to the 3 times y to the 15, guess what? You can write it all out, right? Write the 3 and then write the 15. And then when you start counting, you realize, wait, I could have just counted right there. There's 18 of them, right? So math is such a, you could do the long way. But when you get practice, you realize that it's an easier way. I could see it a lot better than before. Yes?
So 2 to the 3rd power
Mhm.
would be 2 times 2 times 2.
Yes. Yes.
So you do 2 times 2 is 4, and then times that by 2, which is 8.
Yes.
Okay.
So 2 times 2 times 2 basically say, I'm going to take the 2 and multiply it 3 times.
Right.
Yeah. You're going to be very careful which part. It's not 3 multiplied by 2.
Right.
It's not 2 multiplied by 3. It's the 2 repeated 3 times. Okay? 2, okay, you have a funny look in your face.
Yeah, trying to figure it out. Y to the 3rd, so the dot means times, right?
Yes, in the middle, yeah.
So the answer would be 15 times 3, right?
No.
When you multiply.
Well, you're multiplying the y's, but there are 3 y's here and there are
So you-
15 y's.
Okay, so when do you multiply the little numbers up there?
When do you multiply the little numbers? Oh,
Okay.
there is actually a way that you multiply the numbers.
Oh,
So 2 times 3 times 2. What does that mean?
2 to the 6th.
6.
So, well, I'm going to break it down for the first time. 2 to the 3 is what? 2 times,
2 times
not
2,
6,
8.
2 times 2 times 2. There are three of them. This is what, you're going to have to keep practicing. This is not 6. This is not 6. Okay? It's not 2 times 3. It's 2 times 2 times 2. Okay? And then I have another square. So what am I doing? I'm going to take this whole thing and do it twice. All right? So it's 2 times 2 times 2 times 2 times 2 times 2. So if I don't want to multiply them all together, I just want to count 2's. How many 2's do I have all together? 1, 2, 3, 4, 5, 6, all multiplied together. So it's to the power of 6.
Can I show her something that might help
Yeah.
her?
But guess what? If I wanted to do it, I could have just said 3 times 2. That's a 6. That's when you multiply those two numbers.
Can I show her something?
Yes, absolutely. No, there are many ways of looking at
A
it.
way that I like to think of it, so I don't get confused,
Yeah.
I have to like almost write it all out. So I'll go like this, do like a little rainbow, and I know that the first thing I need to do is multiply 2 times 2, which is 4. And then I still have a 2 left over, so then I have to multiply that by 2. So you cancel these 2, and then you have this one left, and then you do 4 times 2, and that's 8. So 2 to the 3rd power is 8.
But then wouldn't you
It's like-
square the 8 and make it 64 because it's to the power of 2? I mean,
Oh,
isn't that
if you
square?
go this, yes.
Yeah, I was
Yes.
just chunking
She
it.
just chunked it,
so
yeah.
I know, I just wanted to know
Yeah.
if I was right
Yeah.
in the ultimate
But guess what
answer.
though? Sometimes they don't ask you to give they don't give you the answer that is the result. They just want to know if you know how to count the number of 2's, right? Do you see what I'm saying? When I did this problem, I didn't get the answer for this. Because sometimes you may want to look at the answer for and say, do I have to break it down and get the actual number? Or do I need to just count properly?
Right.
Look at the answers they give you first, right? Because otherwise you're doing extra work. In this case, I don't need to multiply it out. I just need to how to count. Because they might tell you that this answer is 2/5. I bet one of the answers will be that, right? Because you just added 3 times 2, which is wrong. One of the answers is probably 2/6, right? One of the answer might be 2 times 5 is 10, right? If somebody doesn't know anything, you're going to go 2 times 5 is 10. No, they're going to make something up. But the idea is that you realize, wait a minute, none of this answer look right. I just need to know how to count the 2's, right? So don't do extra work sometimes. Because you sometimes have only 1 minute to do it, or less than 1 minute. And sometimes we do more work than we need to. Because the answers does not require you to do it, okay? They probably won't have something like that. They probably have something where the numbers are not even correct, right? They might have like, I don't know, I'm just making this up, 50 or something, something where you realize that they all have 2, so I'm not going to multiply out, okay? All right. Good one to remember when you multiply, you are grouping the terms together, okay? Whenever you forget, put a number in it and say 2 to the 3 means 2 times 2 times 2, okay? And 2x is not the same as x squared, not at all, okay? Okay, let's go to another section. Let me see, some of them you guys should be able to do it. This is the one that I was going to show you last week and I forgot. Okay. How are you doing? Are you making? Is this making sense? Can I erase?
Yes.
Okay. So the next section has problem that says I'm just going to do 1, and then you tell me. I'm going to do the all x minus 5. Okay. This is the one that I was going to ask you. Why does it work? What do you have to do to, what is it asking you to do? Simplify. To open the expression. So what do you do when you do this? Distribute, right? You go this, and then you go this. Right? So 8 times 3. Oh, but there's an x there, so what do I do? 24x. Okay, don't forget that. And then this is a positive, and this is a negative. So when I multiply, will be a negative, so that's 40. That's it, that's the answer, okay? But I'm gonna, remember you were supposed to remind me, I was gonna show you a visual way as to why it works. Ready for this? I bet most of you have never seen this. Again, I'm giving you another way of seeing a problem. So, let's say that I have a rectangular, a square swimming pool. Okay, I'm just gonna a swimming pool. And what I would like to do is to expand it. I'm just really rich. I'm going to like expand my, which I'm not. I'm going to expand my swimming pool. Okay. So let's say that this is. I'm going to make some numbers up. Maybe not make it so equal. Maybe it's a little longer. And so say this is 3 and this is 4. Maybe 4. It's a small pool. Okay. Maybe it's just for fish. Okay. 3 feet and 4 feet. Okay. Very small pool. And I want to add maybe another 2 feet to it. Okay, so I have a drawing that says I'm going to add another 2 feet. Not very good at drawing it. I'm going to add 2. Okay. All right. So what I would like you to tell me, is what is the original area of the swimming pool? How would you do it? What is the original swimming pool? How big is it?
Square feet.
Original area? Just kind of on the surface, right? On the surface is 3 times 4,
12
right?
square feet.
12. Okay, so it's 3 times 4. That's how you did it. So tell me, in the new one, what is the new area?
18 square feet.
How did you get it? Okay, 3 times. Where did the 6 come from?
4 plus 2.
4 plus 2. So can I write 3 times? This is in your head, right? This is what you did. Yes? This is what you did. What is another way of saying this? What did you just do actually? Think about it.
So you
I could have said that it's 3 times 4, which is the original. And what is the extra area that I'm adding? This is the extra area. How big is the extra area? It's 2 times what? 3. Guess what? You get the same answer. Think about it. So when you distribute, you can almost think about it as I am spreading the area. I started with 12 and I'm adding 6. So when you distribute 3 times 4, you get 12. You distribute 3 times 2, you get 6. So 3 times 4 is the first section. 3 times 2 is the second section. This is a visual way of thinking about distributing. You did it without even thinking about distribution, but that's what you did. Do you see what I'm saying? I don't know whether you got that. So you did it by 3 times the whole thing, 4 plus 2. Another kid might say, wait, I already know the 12. What do I have to add? It's 3 times 2, which is 6. You get the same answer. But that's distributed rule, right? You're distributing this number, 3 times 4, and 3 times 2.
So you're saying the extension is only on the top but not to the side?
No, think about it. So 3 times 4 is 12.
No, I'm talking about visually.
Yeah.
Length.
Yeah.
So you started with this area, and now you have added 2. So therefore my 3 doesn't only go with 4 anymore. My 3 has to also go with 2. Right? So you go 3 times 4 is the first section, and then 3 times 2 is the second section. So when you distribute something, you can think about this. 8 is the side, right? And you have 3x is one section, but now you're actually subtracting a section. So you have to spread the 8 to the first section and subtract 8 times the second section. When I do this with kids, we spend like 3 days on this. I'm giving you like 5 minutes, okay? But the idea of understanding the distribution, that rule, is not magic again. It is not magic. okay? You could actually draw it, you could actually see that you are expanding or shrinking, say a swimming pool. That is a real problem. We actually use the swimming pool to do this problem. Yeah, it's kind of cool, okay? All right, let's go to the next section. I'm gonna keep going because there's quite a lot here. Simplifying variable expression, do you think you guys can handle that? Maybe try it. What is the section that you think maybe you guys would like me to do a problem? Which section?
The word problem?
Huh?
A word problem?
A word? Oh, okay. So you think you could do some of this? You could, could you try it and maybe do some of the problems? And you think maybe if you go to, do you guys, oh, I wish there was
Page
numbers. I
yeah.
know. How about the one step with fractions? If you keep turning, if there says one step equation with fractions,
The form 8x is b.
it says literally
Equation in
one step equation with fractions. Yeah. What do you think about those? Do you think you can try that? Maybe you want to try one of those and see if you can do it? Because once you have fractions, some of you get very like anxious about fractions.
Well, I don't even know where to start.
Okay, all right.
I mean, that's
Okay.
why I'm here.
Okay. So I think you could do you think you could do the one-step equations, the page before?
Excuse me. I think it could have been wise if you could do one problem from any one of them.
Okay.
To go with that.
Okay,
Yes. Yeah.
so,
Pick your poison.
all right. I thought I wore less today and it's still warm in here. Or is it just me because I'm like, I'm using a lot more energy up here, right? So make sure that I'm on the right page. There are no page numbers that drive me crazy. How about solving equation in the form of x plus a equals b? Or do you think you want to do more about solving equation with one step?
We can do the one step equation first, because it's kind of like refreshing how to do the fraction.
Okay. Okay. Let me do this. Let's say I want to do number 13. Okay. And you this is the one that says minus 6 equals to b over 18. So whenever you have problems that have something in there that you don't know, your goal, so this is some sort of relationship, okay? It means that when something is a negative 6, there's some number that will make it equal, right? So this is the way you think about it. So how do I isolate b, okay? How do I isolate b? So in this case, there's an 18 there, okay? So I know I either need to subtract 18, plus 18, divide 18, or multiply 18. What do you think, which one do you think I should do to isolate b? Would adding 18 help at all?
No.
What would help?
Multiply.
Multiply by 18. And why is that? Yes. When I multiply 18 and 18 equals to 1. So the thinking, so I'm giving you the thinking, right? You always think, if I want to get rid of 18, what do I do to get rid of 18? I can multiply, I can subtract, I can, what did I just say? Multiply, subtract, add, or divide, right? Those four. In this case, let's try it. Let's say I don't know and I say I'm going to add 18. I'm going, well, that doesn't help me. It's going to make the problem even harder. Because if I'm going to add 18, I'm going to have to add 18 on this side. And you're kind of like, well, how is that helping me? That doesn't help me. Because this problem makes it even more complicated. So that doesn't work, okay? So then I'm going to try something else. So that's the reason the multiply works. Because the multiply means that this will cancel. But if I'm going to do it on this side, I'm going to do it on the other side. This is where I like to put bracket again because I want to preserve the negative. So I multiply by 18. Yes? And then 18 and 18 goes away. See, now B is like times 1, right? Over 1. So that's why you only got B left. So what is 18 times 6?
108.
6 times 8 is 48. 6 times 1 is 6, 108. And then I have to put negative. Now, some of you don't like that this variable is on the right side. You could switch the problem around too, okay? If you like the variable on one side, you could also do that. That I could make this on this side and make this on the other side. Last week I talked about the balance, right? As long as you don't change anything, the balance stays the same. It's just sometimes people like the variable on the left side. But it doesn't matter, you get the answer still. So always remember, you can get rid of things by either multiplying, subtracting, dividing, and adding, subtracting, dividing, and multiplying. So we'll keep thinking of that. Yes?
So how do we know which one will work?
Well, your goal is to simplify. Okay? If I add 18, because I want to get rid of 18.
Okay.
If I want to add 18, it's not going to help me. Okay? You can try it, right? Minus 6 plus 18.
And then you add 18 from the other side.
Right, but how is that helping me to get rid of the bottom 18? It doesn't. So if I put this 18 over here,
But don't those cancel out like 18
Yeah.
plus 18?
right, they will cancel out, but then you're still left with the same problem. You haven't changed anything. So let's say we do this. All right? So let's say you say, I'm going to cancel out the 18. Guess what? I put the 18 on this side, right? I subtract the 18, right? I subtract the 18 on both sides. Right? Yeah, I cancel out. Guess what? You haven't solved for B. See? You still have not solved for B. The idea is I want to have the problem to end up with B equals to something. Okay? So whenever you don't know, just try it and you realize well, that didn't help me. So if you do it a few times, you realize when something is a divide, you multiply. See that? Because the divide and multiply will cancel each other.
Okay.
Right? So this one pairs together. Just like what you did. If I add 18, I want to take away 18. I subtract 18, I subtract 18. Right?
Yes, I mean,
Add,
I understand.
yeah, add and subtract goes together. Multiply and divide go together.
So whenever I see multiply, I
Yeah, or divide, depending on whether the number is at the bottom or at the top. Does that make sense?
yes.
Right? But the idea is that you always think of 4 ways. Okay, okay, so let's try another one because this is very important. You guys sometimes get stuck and say, how do I know how to get rid of B? Right? How do I know that? It's because if it is a divide, if I multiply, I would make it into 1. So this is the goal of becoming 1. This is the goal of becoming 0. That's the difference. I want to see whether you understand that. When you say 18 minus 18, you cancel out, you become 0. Because when you plus and minus to balance something, if I add and subtract, it cancels out. So my goal is to get to 0. But when you multiply and divide, you can't go to 0 because then it's like infinite. You can't divide something by 0. So therefore, you're going to get to 1. Like something divided by like 18 divided by 18 or 1 over 18 times 18 gets me to 1. Right? So plus and minus, the goal is to get to 0. Divide and multiply, the goal is to get to 1. So in this case, I don't want to get to 0. I want to get to 1. See that? Because this is a divide. This is a divide. Okay? We can do another one because this is actually a very important point. Because like you said, how do I know which one to do? Right? Is there another one maybe on another page that you want me to do? Maybe a little bit more complicated one? 19? Sure. Can I erase now?
Yes.
Okay. I think more, that's the part that you want to maybe write down. 19. Is that this one? 21 equals to minus 7, and is that this one? Is that this one?
Yes.
Okay. Same idea. You want to get to a point where your answers is n equals to something. That's your goal. Solving something means that I want n to be equal to something. In this case, I have a number. Remember when you have this, there is a little invisible multiplier. So how do I get rid of negative 7? Yeah. Okay. Divide by negative 7. Yes. So I will have 21 divided by negative 7 equals to negative 7 divided by negative 7n. Right? All of a sudden, this is gone. Right? And then I'm left with n, and what is my answer here? 3.
But if it was a negative 21, it would have become a positive.
Yes, if this was a negative 21, then your answer would have been 3.
Cancels out.
Yeah.
So like number 20, right?
And you know how I know it's correct for this kind of problem? What if I put negative 3 in there? Would that be the right answer?
Yes.
Negative 7 times negative 3 gives me 21. So sometimes when you solve something, you could take that answer and put it back in the original. Okay? Because sometimes you may have just added something wrong. You go, wait, that doesn't make sense. Maybe it should be a negative or it should be a positive. Okay? Is that helping? Kind of like, this is very important, right? Understanding, do you want to go to 1 or do you want to go to 0? Okay. How about, yeah, these are one step, so it's really, I think you guys get this kind, right? This is, the plus and minus are a lot easier for many of you. I'm going to pick one to do. So this is number 23 on the next page. Negative 16 plus x equals to negative 15, because there's just too many negatives in there. So we'll see how to do this, okay? I want to get to the answer where x equals to something, right? This is 1 times x, so there's nothing to get rid of there. But I need to get rid of 16 then. So do I multiply, do I add, do I subtract, what do I do?
Add.
Right, because here I want to get to 0.
0.
Right, so I'm going to go plus 16 minus 16 plus x, and I'm going to do it on both sides. Did I add? Yes, I add. I'm going to be careful. What did I do? I added. You've got to be very careful. Are you adding or subtracting? Right? Make sure they are exactly the same. A balance. I think I draw it the last time, if I know how to draw balance. The idea is that whatever you do on one side, it has to be the same on the other side. Things are still balanced. I have not done anything, okay, to change it. But now, what happened to plus 16 minus 16?
Cancel out.
Hence, that's 0, right? Then you're left with x. And what is minus 15 plus 16?
1.
Is it negative 1 or 1?
1.
How do I know that?
16.
How do I know that?
The 16 is bigger than 15.
There you go. Think of money. I owe 15, and now I earn 16. I actually have